Okay, so the English session. So firstly, today we'll discuss about trapezoid rule. So because this was some people had a doubt in the previous week regarding this. So we'll start with the diagram first. So basically in trapezoid rule, what we are trying to do is that, like, let's say we have some like curve, like we have some let me write it like this. So basically, let's say we have some curve like this, and let's say we have a like curve like this, okay? And what basically we try to do in trapezoid rule is that, let's say we have a point, maybe x is equal to maybe 1, and another point maybe x is equal to 4. So we want to find the area from this point to this point under the curve. So in like in trapezoid rule, what do we do is that, like, let's say this is okay. Let's see, this is this only, and let me just move the green line, make it slightly different. So let's assume that this is the line that we're trying to like estimate. This is the like curve of some equation. So this like the height of this and height of this is like different, obviously, well. So the question is that, like, how to find the area. So since this is a curve, it is difficult to exactly calculate. So in trapezoidal rule, what we do is that we try to estimate, we try to approximate the area under the curve. So like, what would be the estimate here? Like, uh, let's say uh, this one. So I want the area with under the curve. Okay. So one thing that we can do is that uh, we can draw a trapezium like this. Like, this is obviously one straight line. Okay. This is one straight line. This is a straight line. This is another straight line. And let me draw a straight line from these two lines. And let me say that I want to calculate the area of the trapezium instead of the area under the curve. All right. So what is happening is that if I calculate the area of the trapezium, it is quite similar to the area under the actual curve, but it is not exactly the same. So because you see, like, this part is also under the area, this parts, but this has not been considered in the trapezium, right? So this is like this is actually the deviation from actual value and the like our prediction. So one easy way to solve that is that if we use multiple trapeziums, so let's say we have a trapezium here, okay, another one here, here. So let's say we draw a point like this. So this is one point, okay. Then another point like this, which is like this, another point like this. So you can see that in this case, again, there will be some deviation from actual, like there will be also some blank space here, which we are like, it is kind of like, it is not really exact correct estimation of the area under this curve, but still like it is some kind of a better estimate compared to the using a single trapezoid. So I will discuss it with an example. So basically, let's assume that this is the curve that we want to like estimate the value. like estimate the area under which. So this is the point A, and this is the point B, and I want the area between point A and point B under this curve, right? So how to do that? So this is the basic formula. So B minus A. So B is the end point, A is the beginning point, multiplied by f of A, which is like if is the equation of the curve, and f of B, which is f of A. So if is the equation actually of the curve, we pass x equal to A here. So here, like if x is equal to 1, so we pass 1 here. Similarly, like within the same function, we pass like x equal to B, which can be 3, 4, or anything else. So let me actually go straight to an example here. It will be more clear from this point. So basically, this is an equation. So x squared into e power 2x. Okay. So I want to find the area between is like 0 and 3, which is like a and b. So how to achieve that? So basically, what we have to do, we have to find. So we have to think the equation b minus a. So b here is 3 minus a here is 0, okay, multiplied by f of a. So x square. So x square is 0 into 0 into e to the power. So 0 into 0 is 0 into uh, e to the power 2x, right? So again, this will be 0, but I'm writing it anyway. Then multiplied by, okay, this is one thing, f of a is done, plus f of b. So what is f of b? X square. So x square here is 3 square is 9, all right? 9 multiplied by e to the power 2x. 2x here is 2 into 3 equal to 6. So it is like e to the power 6 divided by. So it will come up like this, 3 into 0 plus 9e 6 divided by 2. So if you calculate that, you can like estimate the number like area under this curve. So if you put it like this, so 9 into 6 is square. So this value is 3,630. All right. So you have to write it like this: 3 into uh, 0 plus 3,630 divided by 2. So ultimately, this value is like 5446. So it is basically the area under this equation from 0 to 3 is this much. So this is like only one segment. We are just drawing one trapezium. So what if we draw multiple trapeziums? So I'll come to that. Okay. So assume that we have another equation. Okay. And we don't know the equation here yet, but we know the x value and y value. So like assume that we have a graph. Okay. Like x is if we take the y value corresponding to the like x1, it is like 4.32, then 1.6 it is 4.7428 like this. So what to do for multi-segment trapezium? So again, there is an equation. So this is the equation for multi-segment trapezium. You have to consider the y0. So in that case, it is like the initial values of uh, the y, which is 4.32. Let me just write it here. 4.321. Okay. So okay, each here is yeah. I'll come to that. Let me just write the equation here. 2 multiplied by Okay, at first, the initial value is just a second. Okay. So at first, the initial value here is that h here is like what is the increment? Like it is going from uh, 1.4 to 1.6, and 1.6 to 1.8. So the increment here is 0.2. So 0.2 by 2 is 0.1. So this one is done here. Then y0 here is 4.3215, okay, plus 2 into y1 here should be 4.748. Then next is 5.5205. Then next is 6.0525. Okay, so these three are done. Finally, we have 6.8762. So one thing to remember here is that like if it is like the first and the last point, there is no multiplier here. But if it is like any of the midpoints, there is like multiplied by 2 here, like y1, y2, y3, the midpoints. Like if assume that there are like 10 points, then like the more points will be multiplied by 2. Only the first and last point will be not be multiplied by 2. So this is how we calculate this thing. So basically, I have written the equation like this. So 0.2 divided by 2, then first value plus 2 into second value, third value, fourth value, plus like 1 into the final value. So if you calculate that, the answer is 4.329. So if you have any doubts on this, please let me know. Either like single trapezium or multiple trapezium. Okay, so then let me continue. So then we'll come to Runge-Kutta method. So basically in this method, what we try to do is that assume that you are trying to climb a hill, and let's say you are currently at maybe 500 meters of like height. Height is 500 meters. Now you want to estimate like at what height you will be after maybe 10 minutes. So assume that angle that you are trying to climb the mountain is at like 30 degree or 45 degree, whatever. So one basic simple way that if you just calculate with the angle, uh, like you will get the value like at this slope after 10 minutes, that will be the or maybe not even minutes. Like let's say if you like go for another 100 meters, that will be the height, assuming that that hill has the same slope integral. But that may not really be the case, right? So basically, what you are trying to what Runge-Kutta method tries to do is that you have some initial value, or like you know you are at like at this distance and at this height, and it tries to estimate that what will be the slope after some time. Okay, and based on that, it tries to predict that the final the final height at maybe at some future point. So and that is basically Runge-Kutta method. So I'll come to one example here. So let's say you are at T0, so you are at a hill at some point here right now, and you have y0 height. Okay, so what would I do is that and I want like T1 means like I want to maybe after 10 minutes what will be my like height, what will be my height in the sense what will be my elevation in the hill. Okay, so at point at this point you can calculate the slope, right? Like slope is like basically just like uh, you can calculate the slope from the y and the x. Okay, then uh, what RK methods is suggesting is that you take another you try to base the height and the slope at midpoint. So midpoint is like here, like let's say after 5 minutes. Okay. So you try to calculate the estimate based on like you said that initially the slope was K1 and I came for 5 minutes. Now the height is supposed to be this much, and based on that, the slope is supposed to be this much. Okay, but like you are using an outdated value of K1, so that may not be the actual slope, right? So what do? You refine it again. At same point, you say that like okay, I have a better estimate of K2 now, like slope. So let me again refine that and calculate the new height of the better estimate of the at after 5 minutes. So you get a new estimate here. So this is a new slope. Based on that, you estimate like what will be your height after like 10 minutes. So basically, you estimate at first you estimate K1 based on your current estimate, like current Y and X, which you already know. Then you estimate the K2 and the height at midpoint at with the help of K1. Then again, you take a better estimate of the height at the midpoint with K2. Then finally, you try to estimate the value at like after 10 minutes, which is the point we are trying to estimate using value of K3. So basically, I'll try to show you with an example here again. So these are the basic formulas before going to the example. So K, so example if is like you have some equation, okay, and K1 you get by using the initial point and the initial point of X and initial point of Y. After getting that, you use that slope to get the value of uh, like uh, at the midpoint, and using that you get the slope of you get the slope K2. Now at the same point you use again the K2, you use K2 again and get the updated slope at the midpoint. And using the midpoint again, using the K3, you attempt to get the new value of Y at point x0 plus h, which is our target. I will skip all this and I will straightly go to the equation. Okay. So basically, what we are trying to find here is that uh, we are given one point that at x equal to zero point 0.5, the y is equal to 2. Okay. And what do we have to find is that we have to find at x equal to 0.7, what will be the value of y. Okay. So basically, what do we have to do is that uh, like uh, at first you have to rewrite the equation. So here, if you see here, what what are you trying to map, estimate is that for RK method, you have to kind of rewrite the equation so that in the left hand side only dy dx is there and everything else is on the right hand side. Okay. So initially this is the equation. So what will happen if you move the x squared to the right hand side? So it will become y cube minus x squared because positive is there. So in the right hand side it will be minus. Then 4 multiplied by is there. So if you move that to the right hand side, it will be like 1 by 4. So f of x and y is 1 by 4 into y cube minus x squared. Okay. So now it becomes so you have this equation. So now the question is how to estimate the K1. So K1 is basically just use the value of x0 and y0, right? So what is the value of x0, y0? X0 is 0.5 and y0 is 3. Okay. So what do? You just put uh, 0.5 here and 2 here. So what will become? 2 cube minus 0.5 square. So 2 cube is 3 and 0.5 square is 0.25. All right. So 1 into 4 multiplied by this. So 0.8 minus 0.25 is 7.75. So it is like this. So after solving the equation, so you will get uh, like this value, like this value is 1.11975. But you remember what do you have to do here? You have to add. So here, just a second. So like at this point, you got the K1. So K1 is like straightforward. You are just multiplied this with equation. You are just giving the values of X and Y here, and you get the K1. Now, what about K2? K2 is different thing. K2 is you have to consider K1 multiplied by uh, H divided by 2. So basically, here, so you have to consider one thing, X0 plus H divided by 2. So what is H here? H here is 0.2. So H divided by 2 is H divided by 2 is 0.6, and uh, H divided by 2 is 0.6, and Y0 is 2 here as it is, plus what is K1? K1 value you already got here. So 1.1 divided by 4, like 7.75 divided by 4 is 1.975. So that is K1. K1 multiplied by uh, H uh, H by 2. So basically this is the equation. So uh, K1 into H by 2. So H is zero point 0.2, zero point 0.2 divided by 2 is 0.1. So here you have to basically do Y0 plus K1 into 0.1. So that's what we're doing here. 2 plus the K1 into 0.1. So at K2, you get a better like you get an estimate that what is the slope, like K2 is the slope at point uh, at like point at the midpoint. Okay. So this is initial guess. And like we are saying at midpoint, the X is 0.6 and the Y is 2.1937. Okay. So this is at K2 at midpoint. Now again, whatever we have done here, this is just estimate. Like this is not necessarily true at all. So what do? We try to refine the uh, Y value and K value at the midpoint value. So next step, sorry. So the next step is just a second. K3. Okay. So next step is that we will use the value of K2, which we obtained here. So K1 we got 19375, 1.9375. K2 value we got it from here. Like here I have mentioned, like if you add this, the value will be 2.19375. So that is the value of Y. Okay. So now you have to put the value of X and Y to again this equation. Right. So if you put the value of X and Y into this equation, you will get uh, 1 by 4 multiplied by X is 0.6 and Y is 2.1937. Okay. So if you put the value of Y and X into this equation, you will get the value of K. So now at this point, we have K1 and K2. Now I'll try to estimate K3. So K3 is like you have like similarly to the previous one, instead of K1 here, you just have to use the K. So like X is also the same, like zero point 0.6 only. But here, instead of earlier, if you remember, we used this one 1.9375. But here we will use 2.54937. So the same equation. Now the updated value is that 2.2549. So this is the updated Y, not the K3. Okay. So this is the updated Y. Based on that, what do we have to do? We have to again put the value of 0.6 and 2.2549 into this equation. So 1 divided by 4 into this cube minus 0.65. So again, we got a value which is for K3. So this is like 2.7764 something value. Now we'll come to the K4. So K4 is the endpoint at which we want to estimate the value. So K4 is like you have to, K4 is like the endpoint. So it is like plus H, not H by 2, because H by 2 is midpoint. So at this point, this is like 0.7, and this is we have to estimate. So how to estimate this Y0 plus K3, which we got from the earlier step, multiplied by the H. So this is again, you remember this should not be H by 2 because like we are not trying to estimate the midpoint. We are trying to estimate the endpoint. So if we calculate that, we'll get an updated Y, like then not updated Y, it is like estimate of the last point that we are trying to like estimate. And based on that, we can calculate the K4, which is the slope at the last point. Okay. So based on the K1, K2, K3, K4, we can calculate a equation like this, like the rough estimate of the point that we're trying to estimate. So the formula here is that this is the initial point. So initially the x like y was 2. So 2 plus this is the step size, which is 0.2. All right, divided by 6. Why 6 will come. So after that, similar to the trapezoid rule actually. So what we have to do is that the first point is like there is no multiplier. Last point there is no multiplier, but the midpoints have multiplied by 2. So 1, 2, 3, 4, 5, 6. So I'm totally like there is like total 6 so it's that we are multiplying here for the same like height. So we are divided it by 6 to like balance it out. So basically, what happened here is that we got like four estimates for like uh, four estimates for the like height. So we are giving the priority to the midpoint and multiplying it by 2, and ultimately we are, because they are like multiplied by 2, and totally it is the multipliers are summing to the 6. So this is 1, this is 1, and 2, 2, so total 6. So we are normalizing that back to like by dividing by 6. So now it is like 2 plus 0.2 divided by 6 and whatever the sum is. So this is the final value, 2 plus point like 2 point 2 like 2 plus the value of this. So ultimately we are saying is that initially at zero point 0.5 x equal to 0.5 the y was 2, and we are saying at x equal to 0.7 the y will be 2.5545. Okay, so this is little bit complicated, but like intuitively it is not very difficult, as like you should assume that like you are uh, trying to estimate a point, like estimate value of y at a future point. Like you have the value of x at the value of xy at the current point, and you want to estimate at a future point. But if you take a guess based on the current approach, like current slope, then that may not be a very good idea always, because like the slope might change, right? Like it is not like the equation has the like constant slope everywhere. So to like adjust for that, to get a better estimate, you try to estimate the slope at the midpoints, at some intermediate points, and then you take the like weighted average of all of them. So this is the basic RQ method. So then we'll move on to some practice problems from like all of the weeks actually, because like uh, all of the syllabus has been covered till now. So like I'll start with the function questions. So this is the first question. Please like feel free to answer in the chat box. Okay, so I got many options that what the function prototype is being used for. So mostly the options, correct options is you have wrote is C, and this is actually correct. So basically, in functional prototype, what do we tell the compiler is that we are not defining the function yet, but we are saying that we are defining the function somewhere down the line, and these are the like arguments. These are the like return. These are the like prototypes. Like these are the maybe the we are taking two integers so that like compile if somewhere down the line we are trying to call the function, the model will the compiler will know that this is not a like error, like this function actually exists. Okay. So next question, what is the default return type if it is not specified in the function? Okay, so I'll come to the RK method later. Continue in MCQ for now. So actually the answer is not a point. The answer actually here is integer. So even for if you consider int main, okay, so if you don't give int, it will automatically assume that the return type is int. So in C program, the by the default operation, like default return type is always integer. Like if you want something else, you have to declare it. Okay, so in this question, how many times I will be printed? So basically, in C, the answer is correct actually. Like it will not be printed because if you in C, if you declare a global variable and they like all the variables, global variables in C are initialized with 0. So here, while I here is like 0, so it will only it will not be printed at all. Like it will come out of this loop and like it will not print anything. So fun will not be printed at all, like because if fun is within this fun is being called within the while function, within the while loop, and since it is not going inside this loop, it will not go. Okay, next question. Any answer to this question? the sum of, but see that there is a divided by 6, right? So will that be considered? Mm, 2.1. Okay, so actually what will happen here is that let me go to this slide again. So what will happen here is that note that I equal to 0, I less than 6, I plus plus I. So even if it is plus plus, but it will occur after like initially initialization is done. This checking will be done. It will go inside the loop. After completing the loop, then only plus plus I will be executing, right? So like it will take this. So what will happen? At first, we will add like age of 0, which is this one, then age of 1, which is this one. So it ultimately what we have to do is that we have to call everything, which will be stored in sum, and then sum divided by 6. So let me just add all of them. 23.4 plus 55 minus 22.6 plus 3 plus 40.5 plus 80. So 162.5 divided by 6, which is 27.0. So here the answer will be 27.0. Okay, so next question. Note that this is not an integer, this is a vector x, and then we are doing integer comparison. So what will be the output? Will there be a single output, or like it will be infinite loop? Or if it is infinite loop, what will be the like starting value and till which values it will like loop?
Hello, sir.
No.
Sir, I actually have a question that is not related to this.
Mhm.
Uh, our exam is in on 17th, and I still haven't gotten my hall ticket.
Okay, so for that, let me just check this.
Okay,
Uh,
sir. Actually,
there
can
should
I
be some
ask
like uh,
people in this if they have gotten their hall ticket or not?
yeah, sure. Like if anyone got the hall ticket, is like it turn yeah. Like you can talk here.
Yeah. Did anyone get their hall ticket?
No one got the thing. So I think I saw
Uh,
some. Yeah, go ahead. There's some people listen.
I can see 3 people who have received the hall ticket, so but I have not received.
So I'm trying to find the mail ID or you can contact actually.
Sure,
So
sir.
I think I saw a discussion in the forum as well regarding this.
Oh,
So,
for the people who have received the hall ticket,
oh, sorry, I couldn't hear you.
uh, I was asking the people who have said they received the hall ticket. When did they receive the hall ticket? Is what I was asking, sir.
Okay, okay. So yeah, please respond if you
Yesterday.
please share. Let me just.
Sir, do you know where can we find the hall ticket if they have sent it to us?
That I'm not sure. Like, can anyone mention? Like, did you receive by email? Like, they received by email.
Oh, through Gmail.
Also, can you
Thank you.
check your spam? Like, it may
I'm
also.
checking it right now.
Okay, but yeah, if it is not like if you didn't receive it, you can mail to this one, support at eptl.itm.ac.in. So they usually respond very fast.
Thank you, sir.
So let me continue here. Okay, so okay, let me wait for more answers. So we'll start with 120, but why on 20 here? ASCII value, okay, but why it will start with 120 only? Like why not 119 or okay, you are saying ASCII value of 0 is 120. Is it so? Let me just check one second. If ASCII value of 0 is 48, so that is not correct. But regardless, like that is not that's not the thing which is having here. See here, we are not assigning a character, right? We are not assigning something like this. Like if I assign character x equal to 0, then it will take like ASCII value of x. Okay, so I'm not assigning that. I'm just assigning an integer. So it is like it allocate a memory and it will store 0 there. So, okay, so what that is like if there is some ASCII value related uh, corresponding to 0, that is being stored here. Like 0 is stored here. So what will happen here is that like see in character, it is like character is stored as a 1 byte, right? 1 byte signed integer. So what is the range? Range is minus 128 to plus 127, right? So what will happen here is that initially we have x is equal to 0, then it will be like it will print 0, then it will print 1, 2, like this, it will continue. Then it will also print 127. But now after 127, what will happen? It will go to 128. But remember, character, it is like 7 bit for numerical value, 1 bit per second. So it will not be able to store the 128. So that will actually overflow to minus 128. So minus 128 to minus 127, like next is minus 127 because last one minus 127 and so on. It will continue. Again, it will come to 0. Then it will continue to again 127. So it will start with 0, go to 127. Then it will look to minus 128 to plus 127. So this will be the loop. So 127, like 0 to 127 will be the starting. Then it will look to like minus 128 to 127 continuously. Okay, next question. So how many times a factorial function will get executed? I don't want the value of factorial actually. Like I want how many times will the factorial function be called? Okay, so 10 is close, but not really the answer. So you have to consider that there is one function called here itself in factorial. So first of all, here uh, first call is factorial of 10. Okay, so let me just count. Let me just write it here. First call is factorial of 10. Now, after going there, what will be the second call? Like it will go to this function, then it will call n into factorial of 9. The second call is factorial of 9. And so on, it will continue. Third is 8, fourth is 7, fifth is 6, 6 is fifth. Okay. Then ultimately at ninth call, okay, let me just write it like this. Third call is 8, fourth call is so it will like at each step it is reducing by 1. Ninth call is 2. 10th call is 1. So at 10th call, it will come to factorial of 1. Okay, so we'll call factorial of 1. But see the equation here. It will again call 1 into factorial of 0, right? So again, it will go here. Like 11th call will be there and it will be factorial of 0. So ultimately it will be called like 11 times, not 10 times. So this is solution here. Okay. Next question. What does this function do? Okay, so here, what is happening here is that at first, if you look through the options, we can discard some of the option right away. So first thing here is that this is the base condition, return B. So when we are returning B, when B is greater than C, right? So this condition must be true when we are returning B. So it is not possible that it will find the minimum, because in this case itself, we are saying that there must be a number which is below than C. So like this is the second option is not true. Okay, so then next uh, we are saying uh, like A greater than, so suppose this is false. Okay, so this part is false. Then if A is greater than equal to B, so let me just give with three distinct examples to make it more clear. So let's say A is equal to 3, B is equal to 4, C is equal to, or maybe just let me interchange the number because it is should have this. Okay, let me just try with all the combination. So if you in the exam, if you get confused, you can try with taking some values. Okay, and then checking. So let's assume let's say these are the values. Okay, A, B, C. In this case, what will happen? A is greater than equal to B. Uh, this is false, right? So it will go to the next here. Else if A is greater than equal to B, no. This is again false. So it will do rearranging. Rearranging is what? Like it will shuffle it like this. B will become A will become B, and then C will remain C. So this will happen. B will become 4, A will become 3, C will become 5. Okay. So now what is happening? Now it is like A greater than equal to B. The answer is A greater than equal to B. Sorry, here it is A here. So A is greater than equal to B. The answer is yes. And C is less than B. The answer is no. So B is actually greater than C. So this is false. Next step, A is greater than equal to B. So yes, here A is greater than equal to B. So next step it will go function A, C, B. So A will remain the same only. A is equal to 4. But now C and B will get exchanged. So B will become 5 and C will become 3. So now what it will do, it will compare again. A is greater than equal to B. The answer is no. This is also false. So now it will again rearrange. It will come to this condition. B will become A. So A is equal to 5. B is equal to 4 and C will remain same only. Okay. So now you see it will go through this condition again. A is greater than equal to B. So A is 5, B is 4. So this is true. C, is less than B. So C here is 3, B is 4. So the ultimate answer is ultimately it will return B. So ultimately you see it is returning B, which is the midpoint. Midpoint means 4 is the midpoint. So assume like you didn't start with 3, 4, 5 like this. You can start with any other combination actually. Like let's say uh, I chose like A equal to 5, B equal to 4, B equal to 3, C equal to 4. That is also like fine. Like it is not necessary to have 3, 4, 5. It can be anything. So even with some alternative arrangement, you can see if you look through the conditions, A greater than equal to B. So this is true, and C is less than B. So this is false. So this will uh, be false. So we'll come to the if else. A is greater than equal to B. So this is true. So in the next step, it will be like C and B will be exchanged. So A is equal to 5 and B will become 4 and C will become 3. Now in the next step, what will happen? A is greater than equal to B. The answer is correct. Like the statement is true. C is less than B. Yes, C is also less than B here. So this is also true. So it will ultimately return B. So if you try 2, 3 combinations like that you can come up with a positive place instead of like if it gets too confusing during the exams. Okay, so you can just try some numbers, try to assign some numbers to A, B, and C or whatever the question is, and you can try to guess the value. So the correct option is that it finds the middle number A, B, and C of A, B, and C. So next question. Okay, so one thing to note here is that in this for loop, on the second for loop, you are initializing j is equal to I, and then it is like j is less than equal to I. So this will basically run only once. Okay. So for within each loop, this part it will like sum equal to sum plus j. This will go only once. So what will happen at 10? So initially I is equal to 1, j is also equal to 1. So sum will be uh, 0. Initially it is 0, then it is plus 1. So now sum is equal to 1. In the next step, in the next iteration, I is equal to 2. So j will also become 2. And 2 less than 2, only once it will be satisfied. And then sum will be like 1. If sum was 1 earlier, plus 2. Then in the next step, it will be plus 3 plus 4. So it will be like 1 plus 2 plus 3 plus up to 10. So if you add that, it is like 55. 1 plus 2 plus up to n, up to 10. So it is 55. Okay, next question, it is about pointer. note that like there is a like dereference with start P and then there is a like direct P plus plus. So what exactly will happen in these two cases? Or are they equivalent? So I'll come to the answer and I'll try to draw a diagram for that before coming to the answer. So, okay. So what is happening here is that again, let's say I have some memory, and in this case, let's say it has some array, there 5, and pointer is something which is, so this is P, and initially, uh, we are giving what, we are passing function of array. Okay, so we are passing the array to the function named fun, and we are catching the address of the array with pointer. So this, so pointer actually, it's not this, pointer actually points to the address of the array. So this one, and this is like array 0, and this is array 1. Okay. So what is happening here is that now we are inside the function and the pointer is pointing to here. So star p I. So star p is like dereferencing first. So it is like it is going to the address of the value what is stored here. So it is going to here, and then it is doing plus plus. So what will happen here? It will get incremented. So 6 I will become 6. Okay. Now next is p plus plus. So see there is no dereference. So what it will do is that it will uh, like it is incrementing this address itself. So it will get incremented to the next value, next integer, which is array of 1. So this is like this is now pointing to array of 1. Now again I'm doing dereferencing, then plus plus. So now it will become 10 plus 1, which is 11. So the final answer is 6, 11. Okay, so now we are done with the functions. Now we'll come to the bisection method question. So just a basic question at first. Bisection method is used to find what? Yeah, so bisection method is used to find a root of a function. So like at what value of x the y is equal to 0. That's it. So this is pretty simple. Then let me go to the next question. What is the worst case time complexity of linear search? This one question. And also under what condition, like under, okay, let me under which situation it will go to the like worst case scenario. So please write both the situations. Okay, that is one condition when the number is at the end, but there is also another condition. So yeah, the correct option is order of n, but one condition is that it will search through all the elements if the last if the element that we are trying to find out is at the last position in the array. So that is fine. But there is also another condition. If that element that we are trying to search does not exist in the array, then also it will have to search through all the elements, and then after searching all the elements, it can say confidently we have not found the element. So that is another second condition. So if either of the two condition is there, then it will it has to search all the elements in the array or any other data structure. Okay, so next question. Which search begins at the starts at the beginning of a list and checks all the element? This is getting very related to the last question only. So the answer here is A, like linear search is like it will go through all the elements one by one. Next question, what is the worst case complexity of bubble sort? So in bubble sort, what it does is it iterates through all the elements and multiple times, and it does the sorting of adjacent elements. So basically in bubble sort, what happens is that there are two for loops, one outside for loop, another inside for loop. So outside for loop runs through I equal to 0 to n minus 1, and the inner for loop also run it just tries to rearrange the elements like one by one. Like firstly, you have to you have to iterate n times, and within that you have to again iterate 1 to n times. So like there are some shortcut, not necessarily follows n time, but again that is quite big, and it is proportional to the size of the array only. So like since there are two nested loops, one within the other, so the time complexity is n multiplied by n, so it is like n square. So the answer is D. Then what is the main disadvantage of bisection method? So answer here is answer is B. It cannot find complex root because bisection method is not really that computation expensive, and it is not necessary to be differentiable here as well. Uh, it is guaranteed to converge if you find two values where if their multiplication if you find two values where their multiplication is negative, then that means you are guaranteed to find the value. So again, D is also not applicable. Only B is the main disadvantage. Next question. Uh, you have a pointer. You are assigning the address of an array to the pointer, and then you are doing some operation. Okay, oh, I got an answer 30. Any other answer? Okay, so the answer here is actually 30. So what is happening here is that initially the pointer is initialized at this point. Okay, so it contains address of this. Now in the next step, what I'm saying is that note there is no dereference. We are increasing the address only. Okay? So we are saying that since it is integer pointer, I'm saying that uh, go to increment the address by 3 integers. Okay, so what it will do 1, 2, 3. Now it will point to this. So ultimately, pointer 2 will contain value of this, address of this. Pointer 1 will contain value of address of this. So if you dereference pointer 2, it will give 40. If you dereference the pointer 1, it will give 10. So 40 minus 10 is 30. So ultimately, it will become 30. Okay, this I have already covered. Your No, okay, I have not covered it. Kiran. Okay, so basically, assume in the bisection method, I'm asking saying you how to solve it. So basically, let's say you have this equation, and if I tell you to solve this using bisection method, and I'm saying that initially I'm starting at point x equal to 1 and x equal to 2. Okay, so how to calculate it? Let me show you this way. So basically, in bisection method, what we do is that we take some initial point and we keep on dividing it into half. Okay, and like we choose which in the left side or on the right side of the half to the search next. So initially, let's say I have like 1 and 2, and I have the if I give a x equal to 1 and 1 and 2, so C is midpoint between 1 and 2, which is 1.5. Now I'll find out what is the value of f of x if I pass uh, x equal to 1.5. So I have passed x equal to 1.5 here. I am getting value 18.3783. So if the value is positive, that means I have to search on the left side. Okay. So now what I am doing is that I'm saying that maximum is 50, midpoint is 1.5. So I'll search on the left side. So it is like from 1 to 1.5 I'll search. There is no solution between 1.5 and 2. Okay, so this one. Then again, I'm doing this. I got 5.54. The value is again positive. So I'll again search on the left side of 1.25. So initial value is 1 and end value is 1.25. I'll not consider 0.25 to 0.50. Similarly, again, this is positive. So I will consider it like this. Uh, this is positive, so I'll again consider on the left side only. So 1 to 1.2500. I'll not consider that the value might be between 1.25 1.125 to this or any of these range. Next, again, this is positive, so I will again consider that the final value is between this one and this one. So now if I ask what will be the next point, so see here, this is negative, right? So here, what will happen here is that in A, it will take 1.03125, and in B, will take the same value only. So if it is positive, then B will change. If it is negative, then A will change. Okay, so the next question here. Yeah, so 2 comma 2 is the correct answer, because here again, if I show you through the diagram, so there is a value here. Let's say a is equal to 5, and there is another pointer here. Pointer is pointing to this one. Okay, so then what we're doing is that pointer is equal to pointer minus 3. So we are dereferencing first. So I'm going to this place. I am modifying this to pointer equal to pointer minus 5. So this is like 2. I minus 3. I minus 3 is 2. So it is the change is getting affected in place, right? So whatever value is there, it will get reflected in both the cases. So even if you write pointer A, so that contains the same address as the A. So in both the cases, only 2 will be written. 2 comma 2 is the correct option. Okay, next question. Okay, so the answer is correct. It will be 276, 12, 10. Why is that? I'll come to that. So basically what is happening here is that initially we have an array, and I am assigning uh, pointer to a plus 4. So this is a plus 4 is like this is address, right? So like you have to consider it like this. Uh, Here we have initially it is pointing to here. A plus 4 is 1, 2, 3, 4. So now it is pointing to uh, like 2. So I am assigning the address of 2 to the pointer. Okay. Now I am going like this. I equal to 0, I less than 5, I plus plus. Initially, I'm saying that p of negative 0, I is 0, p of negative 0. So what it will print? Currently it is here only. So negative 0 is like it will print negative 0 is similar to 0. So it will print this one. Okay. So after that, it is like I will become 1, and it is like p of negative 1. So negative 1 is what? Negative 1 is like the previous address. So previous address of the array here is this, and this will print 7. Similarly, in the next step, it will print 6. Then it will print 12, then it will print 10. So in this manner, 2, 7, 6, 12, 10 will get printed. Okay, next question. This might take a little time, but which one is a like good ordering in bubble shot? Like, which is a valid ordering in bubble shot? Initially, the array is like 7, 4, 1, 2. Assume that you are starting the like bubbling or like swapping from left to right. So at first, which two values will be like exchanged? So at first, what will in bubble shot, what happens is that we'll compare 7 and 4, and they will get exchanged. So it will become 4, 7. So all of the options are correct. Then in the next step, what will happen? 1 and 4, since 4 is bigger than 1. So like 7, like 4 7 and 1 and 4 will get exchanged. So it will, sorry. So initially here you have to consider like this. So initially 47182 at this stage we are here. Then 7 and 1 will get exchanged since 7 is greater than 1. So 417. So these two might be correct. In the next step, what will happen? 417 and we'll compare. Okay, so one thing to note here is that at this stage 41728 and 41782, in this case, this is not possible because we just started solving this. We have not come to this place yet, right? So like 2, 8 cannot come here. So this option is also invalid. So only option here is like B. So we can choose it like this. So correct option is B. Then can we declare function inside a structure in C? So the actual answer is no, we cannot declare function inside C program. This is not dependent on compiler this. It is like not there at all for C. So the answer is no. Then in union, what will be the size of this union? So in union, what happens is that it takes the size of the largest element. So here the largest element is the double. So it will store a, like let's say double, let me assume that double is 8 byte. So it will store 8 byte for double only. So all the anything uh, like all the values will be stored in that memory only in unit. So what will happen if let's say I have defined double z. So z equal to, let's say I have given 5.0 and then I'm giving x equal to 3. So what will happen to the double? And anyone guess? Initially I defined the double and then I'm defining x, declaring x. They share the same memory, right? So what will happen to the earlier value? No, it is not about RHS. I'm saying that let's say I have like let's say I have defined a, I'm writing like this. that I'm taking a variable. Okay, let's say just a dot z equal to 5.0 and a dot b a dot sorry a dot x equal to 3. So see like I told like in union it contains memory of only one address, right? Like only one variable, the largest one. So even if I assign x, it will store in the same memory, right? So if I do it like this, what it will do? It will throw an error or it will overwrite. What it will do? So actually, if you write like this, it will override, yes, it will override the previous value. So because it is like same memory only. So if you, all three variables share the same memory, if you just assign some other value to other variable as well, it will override this memory, same memory only. So the value stored in Z will be lost. So I think this is quite straightforward. What is the difference between structure and union? Union takes less memory. So I'll skip that. Okay, so this question, what will be the output? Okay, compilation error. Why is it a compilation error? Can you write maybe in one sentence? Okay, so the answer actually is correct that it is a compilation error, but uh, see in the yes, because it is a constant. So basically in here, p is equal to ampersand of 10. So this is not correct. We cannot give address of some constant. We have to give address of some variable here. So if it is ampersand a, and it is fine. But ampersand 10, it doesn't mean anything actually. It is just a constant. So it will throw a compilation error here. Okay, next question. So we have a like a variable called pi, and I am assigning the address pi here with type point. So that is the catch here. So you remember like pointer can take all kind of value, right? It can take character, it can take integer, it can take float. So if I want to actually print the value of like 3.4, 3.14, how will I have to do it? Or if you think something other than these code options, that also can mention. Okay, so yeah, you are totally right here. So basically, see, as in float, suppose let's forget about pointer for a minute. So let's say you have something like this. Like you have int x equal to 4, and for some reason you are trying to convert it to something like this, like uh, y is equal to x, and you deliberately want it to have float type, so you have to do what float like this, or maybe other way around as well, because the integer to float conversion will be like implicit only. So let's say other way around. Let me just do it like this. Float x is equal to 4.0 and int y is equal to, if I try to assign it like this, so it will be like int. I'm typecasting it to like typecasting the x. So I have to convert it like this. So in case of void, I'm printing here what? I'm printing the floating point, right? I cannot give the void pointer. Like if I just assuming that it is like your float like float pointer, I can just do it like this, right? So assuming, let me just copy this one. Let me just copy this one. This is not the correct option. Let me just this one. Okay. So assuming that this is the float type, then what do I have to do? I have to simply do this, right? Or float. But it is not float. So what do you have to do? We have to convert from void to float. So what do we have to do? This is pointer is of type. So star pointer is of type void. So we have to convert the void to void pointer to float pointer. So how to do that? Printf percentage here start. Let me forget about for now. Pointer is there. Okay. Pointer is there. So this value is there. Pointer. Now how to convert this pointer to double pointer? So what to do here? How do we define double pointer, right? Like double star, right? Double star. Double star, then variable. So similar to here as well, like just like I convert it like this, integer within bracket, then the variable. Here also you have to write like this, double. But since you're converting to pointer, not really double, so you have to write double star pointer. Okay. So this will be the correct option. So this is the pointer of void type. This is converting it to the pointer double type. And then this is dereferencing that. So this will actually go to the actual address and this will find the frequency. Okay, let me go to the next question. What is the output of the following code? Okay, so the answer here is not C. This is a little tricky question. Let me also copy this code. I'll show you the output as well. Okay, any other guess before I run the code? Okay, so let me run the code now. So this one. We copy here. So, this. So, okay, so answer here is C. Let me check here as well. Okay, so yeah, C is actually the correct answer. I'm sorry. So I got confused. So C is actually correct option here. So basically what is happening here is that here we are here initially the array address of the array is initially 5. At this place, I am changing to like array is equal to array plus 1. So it is going to next address. So array here is now 10. Okay. So if I like print it here, if I print it here, then The answer here is that it will print array of 0. So currently, what is array of 0? It is pointing to here. So array of 0 is 10. So it will print 10. But now you are coming out of this function now. Okay. Now you are here. Array of 0. So now what is array of 0? Array of 0 is 5. But why exactly 5? Why not 10? Because you we use like array equal to array plus 1, right? So we went to the next address, and we keep telling you that in array it is always like passed by address, right? Passed by reference, not passed by value. So if we are changing the array, then that should be reflected, right? But one thing to note here is that like any changes that you make in the array positions, that will get reflected, but any changes in the address will not. So I'll try to show you with the diagram again. So what is happening here is that you have let me check the values here. 5, 10, 15. Five, 10. Let me just copy paste the code here as well. And code here is this one. So what is happening here is that uh, initially I am passing the array to the function. So now initially at this stage, at this point, sorry, even for this point here, array is pointing to what? Array is pointing to here. All right. Now in the next step is here. Array is pointing to the next part, next memory, right? Array equal to array plus 1. Then I am printing array of 0. So array of 0 is 10. So initially 10 is printed. Okay. So now the question is that since array is pointing to this one, array is pointing to 10, and here I am writing that array of this one, array of this one is 10, like array of 0 is 10 here. So why not array of 0, 10 again? Because in like array, it is always passed by reference, right? Every value is being reflected. But one thing to note here is that like if I make any changes here, let's say if I just make it 15 to 20, like maybe just I'm saying 10 to 15. So if you try to print the value there, that change will get reflected. But if you are changing the address here, address change will not get reflected because the array here is actually a local variable. Okay? This one. This is not really. This is just this is just a pointer here. This is not a like in array. What happens is that implicitly the compiler actually sends the address of the so let's say you have an array. Suppose I'm calling function of array. What it does is that it creates the pointer of the array. It gives the address to the pointer to the function, and any changes are made with respect to the same location, right? And ultimately, if you try to access the same memory from the same point, like same location, you will get the updated value. But here, I am not changing the memory. I'm changing the pointer itself. Okay. So, and pointer itself here is a local value. Okay. This is not being changed globally. Okay. So any changes in the pointer will not be reflected back here. any changes in the memory, it will get reflected, but any changes in the pointer, which is array here, it will not get reflected. So any change in address, they will not get reflected in the main or any other function. So ultimately at this place, it will be like array of 0. So array of 0 will be 5 and array of 1 will be 10. So 10, 5, 10, not like 10, 10, 15, not like that. So this is a little bit tricky that you need to remember. Okay, so the correct option is C. Okay, so final question for today. What is the size of the structure? So assume that you have integer equal to 4, integer size is 4 and character size is 1. So 5 is not the correct option here. So basically in structure, what happens is that there is some concept called padding. So for faster and like consistent memory access, the compiler or OS allocates in the multiples of the largest element. So largest element here is 4, and there are two variables. So it will it will allocate based on 4 multiplied by 2 elements. 4 into 8 is equal to 8. So this is done to so that the memory access is faster. So if you have any doubt, please feel free to ask. This is the end of the questions for me. Okay, so let me explain this. So assume it like this. So basically, let's say you have a structure, and structure is basically you have multiple data types, right? So maybe one is integer, one is character, another one is you define it like this. One is integer, maybe 4 byte, and another one is character, which is maybe 1 byte. But this is like 1, this is like 4. But what happens is that in operating system, practically speaking, they access the memory at chunks. Like they will access four bytes at once, maybe. So what will happen? If you are trying to access the character, you will read the 4 byte. Okay. It will also consider some part of the integer. You will ignore this part. Okay. And you will take this part only, right? You will take this. So this is fine. Assume that you want to consider you want to integer. Now what will happen in compiler? You can access either via like this part or this part, this part or this part. You cannot it is addressed via this only, like address at the interval of 4. That's so you cannot access in between, like this to this you cannot access. You have to access this and this. So what will happen? Like you have to get the integer, you have to at first read this part, take this part from that, again read this part, read, then take this part, combine, and then you will get the integer. So you see it is getting like for the accessing the integer, you need two memory accesses. So to avoid that, what does it do is that what compiler does is that for character also it will allocate the 4 byte only, and for this also it will allocate 4 byte only. Okay, so if you want to access this or this, it will take only one memory access to get the element. So this concept is called padding. So what is the largest size of the element in the structure? That size you will multiply that by the number of elements. That's it. Okay. So let me quickly go through the RK4 method. So intuitively assume it like this, like assuming that you are going on a hill and you are like there are two aspects. One, like how much distance did you go from the like base? Like maybe you started from the maybe you are going on Everest, okay? And maybe there is like a base camp, and you walk 1 kilometer to a certain direction. Now your x is 1 kilometer, okay, and y is maybe your height around right now is 2000 meters. Now you ask a question: if I go another 100 meters, if I walk another 100 meters, what is the height? Okay, what is the like y will be? So now one way is that you can see that now the slope is this much. So I can say that if the slope is this constant rate, then after this point, after like 100 meters, this will be the elevation. But issue with that is slope may not be constant. You are seeing that this is now not so steep, but after some point, if you go another 50 meters, you can see that the slope is much more steep, or it can be much less steep. You don't know that. So here, what we do is that at first we calculate the slope at current point. Based on the slope at the current point, we try to estimate the slope, like we try to estimate the y. We try to estimate the elevation at the midpoint. Like suppose we are like this is 1 kilometer, this is 1.1 kilometer. So I want after 50 meters from now, what is the elevation? Okay, I calculated that, and based on that elevation, I calculated the slope. Okay, so now I have a new slope here. Now again, because this is just an estimate, this is not a actual slope because I am not there yet. I will go that like I will after some time. I have not reached there yet. So this is an estimate. I will again re-estimate, but with the updated value. So now this was the K1, which is the slope at current point. K2 is the slope at the next point, like midpoint. Now with the updated value of K2, I will again calculate that if I think that we are considering the slope is K2, then what will be the value of y? What will be the elevation at 1 kilometer, 50 meter? Now I got the elevation at 1 kilometer, 50 meter, and I also got the slope. Now I'll calculate that what is the like elevation at 1.1 kilometer, and based on that, I'll also calculate another slope. That this is the elevation at at the 1.1 kilometer. So elevation and as well as slope. So as you see, like from the arrows, initially the slope was like not so steep, but after some point, like at the midpoint, we can see there's we have estimated that the slope is steeper compared to the whatever we are estimating earlier. Here, it is even more steeper, and at the K4, it is even more steep. So assume that if I estimated it like this only from this point, I would have estimated the gas as this here, right? Just extend the line with we'll think that we'll get at this point after 1.1 kilometer. If I stopped at this point, I'll think that I'll stop at this point. All right. But uh, if I use RK4 method, I will take four slopes, we'll get multiple different estimates, and we'll take weighted average of them. So here it is slope is lower, here the slope is higher, here somewhere in between. I'll consider all this. I'll consider the corresponding value of the y, and then I will take the weighted average. So that's basically what is done. So very quickly, let's say this is the equation. So we already know the x0, y0, x0 is this, y0 is this. And what we have to do is that I have to just put value of x0 and y0 here, and I will get the k1. Okay, so k1 I got. Using the k1, I have to use x0 plus h divided by 2, which is h means step size. So h is given, h divided by 2 is 0.1. So I'm saying that at the midpoint, what is the value of y? So I have this formula to calculate the value of y at midpoint. Now, after we got the value of the midpoint, y at the midpoint, we can get the K2. For K2, we just have to use this equation only. So we have the estimate of y2. We will use the y2 and we'll use the y1, we'll use the x1, and based on that we can find out the k2. Now once we estimate the k2, we'll again estimate, we'll get a better estimate of like k at midpoint. We'll do what? We'll do the same thing. Instead of like x value is same, y value is x value is the same, but instead of k1 here, we'll use k2. So what will happen? Here k2 was there in the k2 was there in the previous step. So x is 0.6 only, x is same, k2 into h divided by 2. So k2 was 2.54 multiplied by 0.1. So again, I'm getting an updated value of y. So, but ultimately we also have to get the k3. So how to get k3? We just have to apply this equation. So we have the value of y, we have the value of x. So again, I am getting a new value of k3. So midpoint is done. Some rough estimate of the midpoint we got. Now let me come to the k4. So you already get the like k3. So like slope at midpoint. Now we have to estimate the y at point k4, which is at the endpoint. So again, we apply this equation y0, which is the initial point, plus k3 into h, and we get the updated y, which is 2.555. So I'm saying that we're estimating that after like 1.1 kilometer, this will be the height. Okay, this will be the elevation, and then from that I can calculate the k4, which is the slope. Okay, so now I got k1, k2, k3, k4, and I got like y0, y1, y2, y3, all this I got. Now the actual elevation is that what is the like not really y1. So this is basically the final value that we want. So what is the actual elevation at point 1.1 kilometer after going 1.1 kilometer? So actual elevation is what was the elevation at 1 kilometer plus this is like 0.2. Like in this case, like you can consider this as like 100 meter, which is 1 kilometer, like 0.1 kilometer divided by 6 plus here you have the k1, which is a slope at first point. This is the slope at the end point, and these are the slopes at the midpoint. So because like they're giving more priority to the midpoints, because like midpoint is supposed to be more representative of the of the curve. Okay, so we are giving more priority to midpoint estimate and low priority to this. So this is not multiplied by 1. These two are multiplied by 1. So this is just a standard formula for report. And if you just put the value of k1, k2, k3, k4 here, which you got from the earlier steps, you will get the final value, that 2.5542. So the actual answer here is that initially, if you consider the hill climbing example, at point after 1 kilometer, I was at maybe 200 meter, maybe like 2 kilometer distance, vertically. But after going another 100 meter or like 0.1 kilometer, we'll come to this distance, like at this point at the this elevation. So actually numbers are not matching. If you go by this example, at let's say this is you can consider this as a kilometer, and this is like just the height. Okay, this is just a meter. Okay, just assume that. So assume that after walking through 500 meters, you came at like 2 meter distance. Okay, like 2 meter horizontal distance. So after going another another 200 meters, so after going to the 700 meter total, you will come to 2.55 meter distance vertical like this. So I hope it is more clear now. Okay, so the recordings will be available. You can always go through them. And okay, all the best for your exams. Thank you very much for joining. I'll end the session.